Hello everyone, and welcome to this theory recording on methods of analysis, where we'll be focusing on analysis by inspection. So what is analysis by inspection? This is a shortcut method that is used to obtain nodal voltages or mesh currents in circuits. It is important to note that a requirement to be able to use this method is that all the sources in a particular circuit must either be independent current sources in order for you to do a KCL by inspection, or independent voltage sources in order for you to do a KVL by inspection. So let's start with the first type, which is the independent current sources, as you can see in the circuit on the left hand side. So we will then do here a independent nodal analysis, or rather a nodal analysis, to then get the currents and be able to express these as a function of the circuit to determine the output values that are required. So how do we go about then solving such a circuit? So in this circuit you can see you've got currents I1 and I2 as the independent current sources, and they're the only sources in the circuit. And then you've got your resistors. So you've got three resistors that have a conductance value G1, G2 and G3. We know that the conductance G is equals to 1 over R. So if you look at the matrix that is formed, we will go step by step to determine how we get to this matrix. So the first step is for us to get an expression of how you would express the voltages and currents in this particular circuit. So we start off by using Ohm's law, and Ohm's law says V is equals to I times R. But then what we do is we express the resistance in terms of conductance. So we then say that we know that G is equals to 1 over R, therefore V is going to give us I multiplied by 1 over G. And if we extend this, we can say the current I is equals to the G value multiplied by the voltage. All right. And given that we have more than one node, we can then express this as a matrix. So we can say G times V, in other words, G11, G12, G21 and G22 multiplied by the voltage V1 and V2 is going to give us the current I1 and the current I2. And this is the matrix form that is similar to what you see there. Now that we have all of this, how will we find the values of G11, G22, G21 and G12? So G11 is known as the conductance of resistors that are connected to terminals 1. So G11 must give you the sum of the conductances connected to point 1, and you can see that that will be G2 and G1. So that will give us G1 plus G2. Similarly, G22 will be the sum of the conductances connected to point 2, which must be G2 plus G3. And that's what you see in this matrix, G1 plus G2 and G2 plus G3. What about G12? Right, so first it's important to note that G12 and G21 must be equal in magnitude, mainly because, again, the definition is going to be the sum of conductances connected between 1 and 2, right? And G21 is the sum of conductances connected between 2 and 1. By that definition, we should be able to pick up that that is the same. 1 to 2 and 2 to 1 is actually the same area. So G12 is going to equal to G21. In a general sense, GAB will equal to GBA. In addition to this, any values for conductance that are not diagonal values. So diagonal values are values that are located in the diagonal. That will be G11, G22, G33, G44, etc. Any value that's not located as a diagonal will always be negative or 0 in value. So we know that this must be negative. And what is the value of the sum of the conductances connected to between 1 and 2? That will give us G2. So that will give us negative G2. So these are the diagonal values that we've got. And then finally, the current values. How will we find those? We look at the terminal. So any current going into the terminal can be treated as positive, and any current going out of the terminal can be treated as negative. So the sum of the currents that would be going into node 1, specifically independent due to the independent current sources. So in the space of I1, we will say there, maybe if we denote it a bit differently, so we'll say small I1 and small I2. So we'll say I1 is going to give us I1 capital minus I2. So I1 is positive going in, I2 is negative going out. And I2 is going to give us, we can see here that I2 goes in and nothing goes out. So it will give us capital I2. And that's what we see on that node. So this is then analysis by inspection using independent current sources. We will then have a matrix that has values for G, values for I, and the unknowns will be V. So we then solve for, in this case, V1 and V2. And in the case of analysis by inspection, when you have voltage sources only, we start off by applying the very same analysis, which would be V is equals to the current times the resistance. And in this particular analysis, we're going to be using resistance in terms of instead of conductance rather. Right, so if we've got a 2x2, we've got two meshes, we know that we're going to have V1 and V2 is going to give us, and we're going to have R1, 1, R1, 2, R2, 1, and R2, 2 as a matrix multiplied by the current I1 and the current I2. Right, and now how will we find these values? So R11 is the sum of all resistances that are connected in loop 1. So that will be R1 plus R3. R2, 2, again, sum of all resistances that are connected in loop 2, that will be R2 plus R3. And remember, the diagonal entries are positive. So that entry and that entry are positive. And then R12, which we should know is equals to R21 from the previous conductance discussion. We should know then that that is going to give us the sum of resistances that are shared between mesh 1 and mesh 2. That must be R3, and it must be negative because it's a non-diagonal entry. So this will be minus R3. Finally, to determine the voltages V1 and V2, we can do a KVL in loop 1 and in loop 2, where we can then say, in loop 1 we can say minus V1 plus the actual V value, let's call that VA and VB, plus VA is going to give us 0, which then tells us VA will give you V1. And likewise in loop 2, we're going to say positive, if we go clockwise, we're going to say positive V2 minus VB is going to give us 0, which then tells you that VB is going to give us minus V2, which is what we see at that point. Thank you for watching this video and enjoy the course.